All right, guys, welcome back to school. Hope you had a great break. So we're going to kind of pick up where we left off, and we're going to do systems of inequalities eventually. But before we can do a system, really want to make sure we know how to graph linear inequalities. So when you're doing this, we're going to be able to graph linear inequalities. We're bringing open and closed and shading, and we can write linear inequalities from a graph. So this one says, what is the solution of the inequality y is less than or equal to x minus 1? So before we get into the graphing of this, I really want to talk about a few key things. If you have a greater than or a less than sign, notice there is no equal to sign under it. We make this a dashed line, or you can graph it with open circles. It means the same thing. All right, if you see greater than or equal to or less than or equal to, that's a solid line, aka closed circles. All right, so if we look at ours, it says y is less than or equal to x minus 1 on this first one. Notice this is going to be a closed circle graph. Now, this is really close to y equals mx plus b form. Actually, it isn't y equals mx plus b form, except for instead of using an equal sign, I use a inequality sign. So, if I had this, could you graph it? Well, yes, we should know how to graph this. Our y-intercept is -1, so I'm going to plot a point at -1, and I'm going to use the closed circle because it's closed graph. And my slope is 1 over 1. So I'm going to go up 1, right 1. Up 1, right 1. Up 1, right 1. Keep plotting points. Or I can go down 1, left 1. Just to show you guys what it's going to look like. So again, I'm going to use a solid line. And now the next and last part of graphing inequalities is to shade. So when you shade, there's two ways to do this. You can do intuition, or you can do a test point. So intuition just means like, hey, I know less than or equal to. If you think about less than, is it going to be above the line or below the line? Well, if you're thinking like intuition-wise, less than means below the line. So I would shade everything on the graph below that line. Now, if you're unsure and you can't use intuition, you can always use a test point. The most common test point we use is 0, 0, which is right here. So I'm going to plug that into my equation and see if it works. So 0 is my x and my y. So I'm going to rewrite my equation using those coordinates. So 0 less than or equal to 0 minus 1. Well, that would say 0 is less than or equal to -1. So now you got to ask yourself, is 0 less than or equal to -1? Well, in this case, that would be no. I would hope you'd say 0 is not less than or equal to -1. So if it's false, I do not want to shade where that point is. So notice that point is above the line. So I don't want to shade that way. Instead, I want to shade below the line, which we used intuition to say already. So shading below the line is correct. So there's two ways to shade, intuition or test point. Whatever way makes sense to you is the way you're going to use. All right, so this next one, I would highly encourage you, if you have graph paper, to pause it and try and graph this. Notice it's just greater than, so this is going to be a open circle, aka a dashed line. Notice I'm still starting at -1. And I'm going to go up 1, right 1. Oops, should have made a open circle. Up 1, right 1, up 1, right 1. So if you notice, it is the same line. However, instead of being closed, it's a open one. So I'm going to use dashed line here to represent that. Now I say greater than this time. So greater than, would that be below or above the line? Well, intuition tells me it's going to be above the line this time. So I'm going to shade everything above the line. So 0, 0 is my test point. So 0 greater than 0 minus 1, 0 greater than -1. Well, that's true. So I want to shade where that point is. Well, if you notice, that point is above the line. So I'm going to shade above the line. All right. So the other thing that you need to know is wherever you shade, the answer to this inequality is any point in that shaded region. So I could use a point up here, a point over here, a point on this. There's so many points you can use. You see all those blue points that I made? Okay. I can use any point I want in that shaded region, and it'll be true for that inequality. That's the whole point of shading. All right? So that's how you graph inequalities, especially linear inequalities. So now I have two more. Again, I would encourage you to pause and try this. I'm going to go ahead and graph this one. It's a open circle graph, aka dashed line, because it's just less than. I'm going to start at a +5 and go down 3, right 1. Down 3, right 1. Down 3, right 1. All right, when you do that, it says y less than. Well, this one's a little bit harder to say, like, all right, where it's above, what's below. So just look at your line, okay? If I go down, that would be below the line. If I go up, that would be above the line. So I'm starting on my line, I go down below the line, because it's less than. Intuition tells me to shade all of this. So again, you can always start on your line and go up or down. Less than would be down, so I'm going to go below the line. Next one, same thing, except for now it's going to be a closed circle graph. But this one's greater than or equal to, so I can start on my line, greater than or equal to. I would go above, aka everything up here. All right. So that's just another example of graphing inequalities. What inequality does the graph represent? So we should be able to write equations based off of what we see. So what are the two things that we need? Well, we need the y-intercept and we need the slope. In this case, our y-intercept is -3, and our slope, I go up 1, right 1, up 1, right 1, up 1, right 1, is 1/1. Now this one, the shading's kind of poor, so we'll do shading below on this one. All right. So when I shade below, I'm going to say y less than or equal to. I use less than or equal to because you notice it's a solid line. So that means I shade solid, has to have the equal to with it. So less than or equal to 1x. So I'm just going to write x. So that's 1/1 minus 3 minus my y-intercept. So I'm just writing into y equals mx plus b form, and we have enough information there to write it. This one, I'm going to shade above. So again, the two things you need are your y-intercept and your slope. Well, my y-intercept in this case is 0. My slope, if you kind of count, I'm going up 1, right, kind of looks like 3, or I'm going down 1, left 3. So your slope is up 1, right 3, so 1/3. Now this one's going to be y greater than, because it's a dashed line, no need for the equal to, 1/3 x plus 0. And you don't have to write the plus 0. You can just say y greater than 1/3 x. All right. Last one. Let's say I shade above again. Notice I start at y-intercept is at 1. My slope would be down 2, right 1. So -2 down 2 over a +1, which equals -2. I'm going to say y greater than or equal to, because it's a solid line, -2x plus 1. And again, these graphs have all the information you need to write them. The last thing I really want to talk about are these special lines. So what is the graph of the inequality in the coordinate plane? If it's just x, this is a vertical line on that number. If I say just y, this is a horizontal line on that number. So we have an example of both. So the first one, notice there is no y in this equation right here, right? I have x greater than or equal to 3. So that's going to be a vertical line on 3. I chose a solid line because greater than or equal to. Now the hardest part is probably shading. You can still use a test point, 0, 0. I'm only going to plug in the x, right? Because there is no y. So ask yourself, is 0 greater than or equal to 3? Well, no, that's false. So I do not want to shade where that point is. Instead, I want to shade on the other side of the line, which would be here. And intuition tells me greater than or equal to, if you look at a number line, 4 is greater than 3, 5 is greater than 3, 6 is greater than 3, and so on. So that's that one. Y is less than 2, like I said, is a horizontal line on that number. Less than 2, I could use a test point. But notice this time I'm only going to plug in the y. So is 0 less than 2? Well, that's a true statement, so I want to shade where that point is. So that's everything below the line. You think about it, less than 2 probably means I'm going to go down, right? So that's how you would graph those special equations. If you guys have any questions over this, please let me know, and I will be more than happy to help you. That is graphing linear inequalities. This is very important that you understand this because we're going to go into systems. If you don't know how to graph one linear inequality, then you're definitely not going to know how to graph a system because a system is 2 linear inequalities. So make sure you know how to do this before you move on. All right? Have a good day, guys.